The Commonwealth trawl sector is one of 4 sectors that make up the southern and eastern scalefish and shark fishery, which supplies most of the fresh fish to the Melbourne and Sydney markets. The Commonwealth trawl sector operates out of ports in New South Wales, Victoria, Tasmania and South Australia, landing around 15,000 tonnes of fish each year, worth about $50 million. The fishery is managed by the Australian Fisheries Management Authority. 34 species, species groups or species baskets are subject to quota management arrangements. But there are other management controls as well, such as gear restrictions, area closures and a limit on the number of fishing vessels. Danish seine gear is one of the fishing methods used in the Commonwealth trawl sector. The Danish seine fleet is based largely out of Lakes Entrance, where they target tiger flathead and eastern school whiting. Danish seine nets are similar to small trawl nets, but are more simply constructed with lead-cord polyethylene ropes instead of warp wires, and no otter boards. The vessel tows the ropes and the net in a circle around the fish. The movement of the ropes and the wings of the net herd fish towards the central net, or the cod end. Like other forms of fishing, Danish seine gear catches not only the target species, but also lower value non-target species, known as bycatch. Some bycatch species are retained for sale and are known as byproduct. Others may be discarded at sea and are known as discards. Fish can be discarded for many reasons, including being undersized or unsuitable for consumption or sale. There's concern over the practice of discarding because it can damage fishing gear, increase drag, which increases fuel costs, and ultimately may affect the ecosystem on which fish stocks rely. A recent global review of discarding in marine fisheries estimated that approximately 8% of all fish are discarded. While trawl fisheries only accounted for 22% of the global landing, they accounted for more than 50% of the total estimated discards. In 1998, a project was initiated to investigate ways of reducing unwanted bycatch by otter trawl gears in the Commonwealth trawl sector. This work not only led to reductions in bycatch, but stimulated continued experimentation of ways to further reduce bycatch. The Danish seine project, funded by the Fisheries Research and Development Corporation, was established to estimate the selectivity of Danish seine gear and to investigate ways of reducing bycatch in that sector. The aims of this project are to find out the optimum size and age at capture of tiger flathead and eastern school whiting, to determine the selectivity of Danish seine gear, and to build and trial cod ends to reduce bycatch while maintaining the value of the commercial catch. Determining the optimum size and age at capture was done by modelling the catch of tiger flathead and eastern school whiting using yield and value per recruit models. Per recruit models are common tools for examining the trade-off between capturing a large number of fish early in their lifespan and capturing a smaller number of fish later in their lifespan. Results showed the standard Danish seine gear used for tiger flathead and for eastern school whiting caught each of those species close to the length that would provide the maximum value per recruit. It was also found that for tiger flathead, the value per recruit does not change a great deal with small changes to length at which they are caught. That's a positive finding because it shows that the gear currently used is appropriate for the target species, and the selective properties of the gear could be modified to reduce bycatch without reducing the value of the catch of the target species. The Danish seine fleet used different cod ends when fishing for eastern school whiting compared with cod ends used to target tiger flathead. Eastern school whiting are a small, elongated species that require a relatively small mesh size in the cod end. The standard cod end mesh size for these nets is 45mm in diameter. In comparison, tiger flathead are a larger, dorso-ventrally flattened fish. Danish seiners generally use nets with 70 to 75mm diameter mesh to target this species. To estimate the selectivity of tiger flathead nets, a 45mm mesh cover was constructed around the standard fishing cod end to capture the small fish that usually escape the larger mesh. This method could not be used for eastern school whiting. Instead, alternate tows were used, whereby the 45mm gear was used in one shot and the 25mm gear used during the following shot. Results found that about 30% of the weight of animals that entered the 75mm Danish seine cod end escaped. Most of the animals that escaped were unwanted fish, such as blacktip cucumber fish, small tiger flathead, round snout gurnard, and eastern school whiting. Comparison of alternate shots of the 45mm eastern school whiting cod end and the 25mm experimental cod end revealed that the smaller mesh cod end caught about 30% more fish, which would otherwise have escaped during normal fishing practices. These species included common stinkfish, small tiger flathead, and round snout gurnard. Another key piece of information resulting from this project was data on the capture of threatened, endangered and protected species. Spiny pipe horse was the only TEP species caught in the 67 shots observed during this project. 7 spiny pipe horse were caught in 6 different shots, with 3 of these fish being found in the cod end cover, suggesting that this species normally passes through standard Danish seine gear. Central to identifying gear modifications to reduce bycatch is looking at fish behaviour in the net. An underwater video camera was deployed during experimental trials. Footage revealed that the majority of the time the Danish seine gear is in the water, few fish move into the cod end. Generally, it's during the 5 to 10 minutes that the net is being pulled on board that the bulk of the fish enter the net. During that rush, most fish either actively swim towards the cod end or fall back into it while slowly swimming in the same direction as the cod end. It's only once they are in the cod end that they contact the net and attempt to escape. Based on these observations, it seems the cod end was the best place to make modifications to reduce bycatch in tiger flathead nets. Modifications to the eastern school whiting nets would be uneconomical, as their shape means that even small increases in mesh size would result in a major loss of the target species. Danish seine mesh is diamond in shape. The shape of mesh means as tension is put on it, the width increases and the opening height decreases. One of the most popular ways of reducing bycatch in otter trawl fisheries is to use mesh that has been rotated 90 degrees, called T90. The orientation of the knots in T90 nets holds the mesh open, allowing more fish to escape. Because the current gear catches fish at a size close to the optimum value per recruit, and because much of the bycatch species are elongated in shape, 75mm T90 mesh was considered a good option for trialling modified gear. A trial of the 75mm T90 cod end showed that it consistently caught much less bycatch, reducing discards by more than 25%, while retaining a similar quantity of commercially valuable fish as the standard 75mm cod end. These differences in catch were largely due to reduced catches of grooved gurnard, round snout gurnard and silver belly. This was the first time that trials of modified gear have been undertaken in Australia with the aim of reducing bycatch in the Danish seine fishery. Results from the trials offer the fishing industry a possible solution to reduce bycatch while remaining profitable. This will benefit not only the target species and the ecosystem they rely on, but improve efficiency and reduce sorting times. Outcomes from this project will also be used in the Australian Fisheries Management Authority response to the Ecological Risk Assessment, which is a key process in addressing the ecological component of ecologically sustainable development.